Hello guys, today we're going to prove that the square root of 2 is irrational, and we're going to prove it by contradiction. So suppose that the square root of 2 is rational. This means that it can be written as p over q, where p and q are both integers, so they belong to the integers set d. And the fraction p over q is reduced. This means that the greatest common divisor between p and q is just equal to 1. It basically means that they don't have factors in common that are not 1. So it cannot be simplified. Now, let's square both members. So we get that 2 equals p squared over q squared. We can bring q squared to the other side. So p squared equals 2 times q squared. Now, q is an integer, and q squared is also an integer. Now, remember that any number m, if can be written as 2 times n, where n is a natural number, m is an even number, so it is even. Now, q squared is a natural number because since q is an integer, if q is negative, the square of a negative number is just a positive integer, and a positive integer is a natural number. So q squared is a natural number. Now, if q squared is a natural number, then p squared is even, because we said that a number that can be written as 2 times a natural number is even. So we know that p is even. Now, if p is even, we can write p, as we said earlier, as 2 times n, where n is a natural number, right? So let's substitute 2n in our previous equation, and we get that 2n all squared equals 2q squared. This is just a normal substitution. Now, if we square this number, we get 4 times n squared equals 2q squared. Now we can divide both members by 2, so 1/2 times this, and this times 1/2. As you can see, we can simplify 2 and 2, and we can simplify 4 and 2, and we get a 2. So this is just 2n squared equals q squared. But since n is an integer, we know that n squared is also an integer, and 2 times an integer is an even number. So q must be an even number. This means that q is even. But we said earlier that the greatest common divisor between p and q has to be 1, because we cannot simplify the fraction p over q. It's a reduced fraction. But if q is an even number and p is an even number, we can write this as 2 times n divided by 2 times m. If p equals 2n, so p equals 2n and q equals 2m. But now they have a factor in common, that is 2, and we can simplify 2 and 2. So the fraction isn't reduced. The fraction is not reduced, and we know that the greatest common divisor between p and q is not 1. In fact, it is 2. And since the greatest common divisor we get between p and q is 2, it cannot be 1. So we go to a contradiction. This is our contradiction. We get that the greatest common divisor between those two numbers is 2, but we assumed at the beginning that it was 1. So we go to a contradiction, and we know that the square root of 2 is not rational. So is not rational. And the fact that it's not rational implies that the square root of 2 is If it is not rational, it is irrational. And we can draw the shaded box or part QED, whatever you prefer, because we proved that the square root of 2 is irrational. If you enjoyed this video, leave a thumbs up, share it with your friends. Don't forget to subscribe to my channel and let me know in the comments what would you like to see next on my channel. And as always, until next time, bye!